Hey guys, welcome back to Car Academy. In this series of video, we are looking into NVIDIA Cuda programming. In the last couple of videos, I have explained about grids, blocks and threads. I will give you a quick recap of what that is again. So a grid is basically a two-dimensional blocks where a block can be indexed using x and y coordinates just like this, and each block is basically a three-dimensional threads and can be invoked or accessed with three coordinates x, y and z. So in the last video I explained about grid blocks and threads using this program. So basically we were printing block dimensions, grid dimensions, block index, thread index, etc. So this example basically allocates a grid with 2 by 2 blocks. What that means is it has two blocks in x direction and two block in y direction, and each block consists of three threads in x direction, two threads in y direction and one in z direction. So basically each block has 3 times 2 times 1, which is 6 threads, and each grid has 2 times 2, which is 4 blocks. So we saw that by running this program, and you can see here, you would see a block index y. Basically you can see here block index x varies from 0 and 1 because we only allocate two blocks per grid. Similarly, block index y also varied between 0 and y. Okay, so basically you will have all the combinations block index 1 1, and you have block index x and y 0 0, you have block index x and y 0 1, you have block index x and y 1 0. Okay, under each block index you see there are 6 threads with different thread indexes. Okay, so this the first block index 1 0 has thread index x 0, y 0, z 0, and you see x is 1, y is 0, z is 0, x is 2, y is 0, z is 0, and now you will see all y1 x0 1 2. Okay, z remains 0 because we only have one thread allocated in the z direction. So we have three threads allocated in the x direction, so that's why you see 0 1 2. We have allocated two threads in the y direction, that's why you have 0 and 1. So there are basically six combinations. As I said earlier, each block has six threads, and that is what you are seeing here, 3 times 2 times 1. Okay, so I'll also go over another simple example to just explain or to basically go over the same concept in a different way. So we will just modify this program slightly so that you can understand. Okay, now let's go and modify this kernel. We'll write one more kernel, but we'll just invoke that kernel 2. Okay, now what we will do is we'll basically calculate the thread ID. So the thread ID is basically nothing but block index dot x times block dimension dot x. So here assume that we allocate or we configure the threads only in the x direction. Now let's go and do this. So thread ID will just print GPU thread ID colon %d \n thread ID. Okay, so we'll just print it here. Now what we will do is since we are allocating only in the x direction, so this is basically not required. Let's comment this since this is more for the explanation. Let's forget about these blocks and grids. So instead, now we have to launch kernel 2. Here you can see, let me allocate only one block, and each block has 4 threads. Okay, so let's go and compile this. You know how to compile nvcc program 03.cu. You can also give a name with -o, but if you don't give, it will generate a /. So now you have 4 threads. It's just basically creating 4 different threads, and each thread has different thread ID. Okay, now let's go and modify this program. slightly. So now we have given four threads. Okay, each block has basically four threads. Now let's go and give two blocks. Okay, so two blocks. Now let's compile this program again. 03.cu. Now if you run now, you can see there are 8 threads. So the way it works is basically you have to think like this. So now what we have done is basically here. Okay, so this is basically a grid. In the grid, what we have done is we have allocated two blocks, and this two blocks is just in the x direction. This is just a one-dimensional block. Just assume that they are both of same size. So this is basically block 0, and this is block 1. And each block here consists of 4 threads. Similarly, this block consists of 4 threads. Okay, so this is basically 0, 1, 2, 3, 0, 1, 2, 3. So what happens is this is block index 0 and the block dimension. Okay, so this block dimension is 4. That's because we have 4 threads in this block. Similarly, this block dimension is also 4. Okay, so the way it works is we have this formula nicely written, which is basically block index dot x times block dimension dot x plus thread index dot x. Okay, so what happens is these are the thread indexes in block 0 and these are the thread indexes in block 1. So initially for this block you have block index 0 for block 0 and block dimension dot x. This is constant, right? This is basically 4 and this varies between 0 and 1. Thread index dot x varies from 0, 1 to 3. So initially for the first block you have block index 0. 0 times 4 is 0 plus 0, so that's what you get as a thread id 0. And then block index, let's again keep that as 0 because you have 4 threads. So 0 times 4 is again 0 plus 1, so you get 0, 1, 2, 3 like that. Then you have 4 threads in the block 1. So now block index dot x is 1 for the threads under block 1. So 1 times 4 is 4, 4 plus 0 is 4. Then the next thread, which is basically 1 times 4 plus 1, which is 5. Then here 6, 7. Okay, so you get basically 0, 1, 2, 3 in block 0 and nice 4, 5, 6 and 7 for block 1. Okay, so that is what we have seen in the program. So this is basically with respect to one-dimensional allocation. So if we just go and modify this program again, let me create another program .cu. Okay, so let's modify this program for vi program 04.cu. So here what we'll do is, so let's just make this as a thread index x. Let's also compute thread index y. That is basically calculated based on thread index underscore x underscore y. This is basically you just multiply block index dot y times block dimension dot y plus thread index dot y. Okay, now what happens is you will basically get it as a two-dimensional coordinates. Thread index underscore x, thread index underscore y. Okay, so you get as two-dimensional coordinates, but let's just go and compile this nvcc program 04.cu. You will still find only 8 threads. That's because we have allocated threads only in the x direction. The y direction just has 0. Okay, so if you have to understand this, what you will have to do is, yeah, now just give dim block. Okay, now let's go and see what happens now when we compile and run. So now you see you have 0 1 2 0 1 2 3 4 5 3 4 5. Okay, the numbers are jumbled, but just ignore that. So you see that there's 0 1 2 3 4 5 of 0 0 0, and you also have 0 1 2 3 4 5 with 1. Okay, so what that means is, just now go and check this program. So what we have done is we basically allocated 3 threads in each block in x direction and 2 threads in y direction. Okay, so that you can see here, 3 threads. Okay, the way it works is basically we have the number of blocks as 2, so there are 2 blocks, which is basically block index dot x and block index dot y. Now each block also has a two-dimensional threads, which is 3 comma 2. So if you go and print block index dot x, block index dot y, now let's go and visualize this. So we have this nice written. Okay, so our configuration is blocks in grid is 2, and each block has 3 comma 2 comma 1 threads. Okay, so this is basically look like this. You have 2 blocks, which is basically allocated in a 1D fashion. This is block 0, this is block 1, and each block has 3 by 2 threads like this, and it is numbered like, so the block index y is always 0. Okay, the block index x looks like this: 0 comma 0 and 1 comma 0. This is basically x comma y. Okay, not y comma x. So you have x comma y. Here you have 0 comma 0, 1 comma 0, 2 comma 0, and here you have 1 comma 0, sorry, 0 comma 1, you have 1 comma 1 and 2 comma 1. Similarly, 0 comma 0, 1 comma 0, 2 comma 0, and 0 comma 1, 1 comma 1 and 2 comma 1. So if you go and multiply this using the formula that we have shown in the program, okay, you will basically get your output like this. You can do your math based on this formula. Now you know what is block index dot x, block index dot y. You know what is thread index dot x, thread index dot y. So basically block index dot x is basically this 0 and 1, this one. Okay, and block index dot y is always 0. This is basically thread index dot x, thread index dot y. So if you go and fill this, you basically get this output. So this is how the blocks and thread indexes are obtained by the Cuda kernel. Okay, so once you understand this concept, you will be able to do parallel programming with arrays, matrices, and various complex data structures. Okay, so if you like this video, subscribe to this channel, share it with your friends. I will come up with another interesting program in the next video. Till we record next video, I'm signing off. Thank you guys. Bye.